Okay, besides cis-trans isomerism, there is a easy isomerism. Okay, let's see this question. At least, let's see this example. Okay, like I told you before that the C double bond should connect it to two different groups. Okay, Br and F, Cl and H. So the first requirement fulfilled by this molecule, right? They connected to two different groups. But the second requirement is the group at the first and the second C should be same. Minimum one groups should be same. It's not fulfill the requirement, right? Since BRCl, FH differ each other. So how we determine the geometrical isomerism for this compound? Okay, I will introduce you about easy isomerism. Okay, in this type of geometrical isomerism, E, the E isomer, this is from the German language, yeah, engage and zusammen, yeah. Engage, that means the higher priority groups are on opposite sides. So this is same like trans. And Z is the at the same side, so this is similar as cis. E trans, Z cis. Please remember about that. Okay. And you can see that according to this statement, E isomer rests if the higher priority groups are on the opposite side. So it is very important for us to know how to determine the priority, right? I should understand about how to determine the priority. Okay, now let's see this first, BR and F. Which one has the higher priority? Okay, to answer this question, I will explain about Chern-Ingold-Prelog rules. Okay, the Chern-Ingold-Prelog rules of priority would be like this. Rule 1. Look at the atom bonded to the carbon double bond. The atom with the higher atomic number has the higher priority. So the first thing you should compare is the atomic number. So let's say compare H and Br. This one has the higher atomic number, Br, right? So Br has the higher priority compared to H. Okay, now let's see the second C. The second C double bond, I mean. This is connected to CH3 and C2S5. So that means CH2, CH3, right? Okay, C and C, same. Rules 2, the second rule. If the atoms are the same, for example, if they both carbon atoms, apply the same rules to the next bonded atom. This means that longer hydrocarbon chains have higher priority. Okay, so the next is for this, this group. The next atom is C, but the next atom for this is H, H, and H. Okay, can you imagine? The next atom is H, H, H for this, but for this is H, H, C. Okay, so you can see that this H, 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 this is H, H, C. So this is higher priority. Okay, so the conclusion is C2S5 has the higher priority compared to CH3. Okay, next we already got the higher priority groups, and you can see here that the priority groups lies on the same side, right? So how about the easy isomer? Is it E or Z isomerism? You still remember about E? Okay, if you forget about EZ, okay, let me scroll again. E if the higher priority groups on opposite side, and Z if at the same side. Okay, so this is Z isomer. Okay, Z isomer. How about to give name about this compound? How if I want to give name of this compound? Okay, so same like at the first video, I already told you how to give name for compounds. Okay, you can see this is alkene, right? Okay, please find the longest chain. This is alkene, this is the longest chain, right? Okay, now give number. This is 1, 2, 3, 4. Okay, there is methyl group at the second C, and then the functional group we are at the first C. This is halogen alkene, right? So the name would be 1 bromo, 2 methyl, but 1 in. Don't forget to put, since it is a Z isomer, so Z in the bracket strip. Okay, Z 1 bromo, 2 methyl, but 1 in. This is the name for this compound. Okay, I hope you understand about this. This is the E isomer. Yeah, if the higher priority group at opposite each other, this is E. Okay, now let's practice. Okay, let's compare your answer with this. 3 methyl pentoin. First, I draw the usual one. 1, 2, 3, 4, 5 pentoin, and then at the third C, there is a methyl group here. Okay, done, right? Now I should draw the geometrical isomer. So I will focus on the C double bond here. Okay, and then I will redraw like this, C double bond, and then two hands like this, open like this. Okay. Okay, this is the C double bond thing. Okay. Okay, this is the first C, this is second C double bond. The first C double bond connected to one CH3 and one H. The second C double bond connected to ethyl, CH2, CH3, and methyl. Okay, which one? Is it a E or Z isomer? Okay, once again, E opposite, that means trans, and Z same side, that means cis. Okay, let's see the priority. H or methyl? Methyl has the higher priority. How about ethyl and methyl? Ethyl has the higher priority. So this is the C 3-methyl pentoin. Okay. To change to E, yeah, you just move this to this or this to this. Okay. I think you already understand about how to make it is opposite each other. Okay. Okay, let's try this. Okay, let's discuss the answer. A different structural isomer of pen 1 shows geometrical isomerism. Okay, so draw the structure of one of the two geometrical isomers with the formula C5 is 10. So this should be pen 2 right? Okay, because pen 1 yeah, not show the geometrical isomer. So the isomers that give the geometrical isomer is pen 2. So let's draw one of the cis-trans isomer of this. Okay, let's draw first pen 2. 1, 2, 3, 4, 5. Okay, the C double bond. C double bond C. Okay, the first C connected to CH3 and H. The second is ethyl and H. This is ethyl, right? This is ethyl. So this is H. So like this. So this is a cheese, yeah? Cheese pen to in, or Z pen to in. Okay, you can also draw the transform or the E form, okay? But because of this question asked about only one, so you can choose either you want to draw the cheese or the transform.